But the way I want you to start out is you should know what kind of materials you need to get out. I'm talking about activity series. I'm talking about a reaction prediction packet, your periodic tables. Get the appropriate materials that you need out so that we have everything that we need right here ready to roll. Now, we're going to talk about this entrance slip. We're going to go over it. And we're going to discuss different parts and how we're going to evaluate it. All right? This was a formative assessment, so you don't have a grade on it. When I went through, I most of the time circled places where I saw things that were amiss. Now, let's look at our objectives here. Okay? I've got my I can statements here, and we're going to talk about the point values. So, being as good as I am at math, I can see 2, 4, 6, 8, 10. 10 total points for each one of these, had they been graded. Had they been graded, 10 points. So if we do an assessment where you're actually on a test, on a quiz, one of these will be worth 10 points. Now let's look. Predict the type of a reaction. That is 2 points. Okay? So I'm going through, is it single replacement number 1? Is it double replacement number 4? What is the reaction? What type? Okay? 2 points for our second objective. Write the formula of the reactants. Okay? So you're going to get points for having the correct formula for the reactants. The third objective, predict the products of the reaction. That's our whole gig here, folks. We're doing reaction predictions. That's our whole idea. So we not only need to predict what's going to happen for 2 points, but also write the formula of the products for 2 points. Okay? So we predict the products, we write the formula. Finally, we balance the chemical equation. That's worth 2 points. Okay? So once again, being the math genius that I am, okay, if I can only do 6 out of the 10, that's 60%. That's a D minus. Okay? If I can do 8 out of the 10, it's a B minus. Okay? What's my goal? I want 10 out of the 10. Because 10 out of the 10 is the A. Right? 10 out of the 10 is the A. Now, when you watch the video over these guys, okay, my notes got a little mixed up here. When you watch the video over these guys, you saw something like this. Okay? Here's the first one. Predict the types of reactions. Okay? This is our first objective. Is it a synthesis reaction? Here's my little cartoon I had. What is it, Mario and Luigi? Is that who those are? Huh? Mario and Luigi, whatever. Okay, I like these better, Mickey and Minnie, with my decomposition. Okay, they're splitting up. Okay, they're splitting up. We talked about the dance. Single replacement was the dance, right? One person cuts in, the other person gets shoved out. Okay? Double replacement. Here are the folks that we had in our cartoon of the double replacement. Okay? They're just dancing with each other. Switching dance partners. Okay? So the double replacement switching dance partners. And this one is just a new one that I found. This one, combustion. Combustion is the player. That's what this says behind here. The player, because we have our, excuse me, we have, in this case, methane here, and then we have oxygen. And then what happens? Well, the methane splits, okay, and the oxygen is dancing with both of the carbon and the hydrogen, okay? So those are our little pictures on the reactions. So let's get to getting on, all right? Here we go. Number 1, okay? Number 1 was lead to chloride. So as I am looking, ladies and gentlemen, what type, my first objective, what type of a reaction is this? Okay? It is a synthesis reaction. I would agree with that. Check, check, time out. This is not a synthesis reaction. I would not agree with that. My bad. Okay? When I have one reactant, what should I be thinking right away? Decomposition. Excellent. I should be thinking decomposition. This indeed is a decomposition. Now, which one? Which decomposition? Well, let's go through them. Okay? Is it number 1? No. Is it number 2? No. Is it number 3? No. Is it number 4? No. Is it number 5? No. So it's got to be decomposition number 6. We just got 2 points, folks. Okay? We just got 2 points. Now, my next part, my next objective, can I write the formula of the reactant? PbCl2. Okay? Some people, like I said before, some people had lead being iron. They had Fe. Okay? All right? So, can I write my reactants right? 2 points. Okay? 2 points. Now, I need to predict what's going to happen. And as I can see on my reaction prediction packet, it says that a binary compound heated, which is my triangle there, heated will yield the constituent elements. So, what are my products going to be? Okay? The 2 elements, which is what? What's one of them? Lead, Pb. Okay? What's the other one? Chlorine, right? What do I know about chlorine, though? It's diatomic. Chlorine's a super 7. Good. So, I predicted the reaction for 2 points. Now, I wrote the formulas of my products for 2 points. I'm 8 points in right now, folks. What's my other 2 points? What? Balancing. Okay? I look at this. I'm already balanced, aren't I? Now, assess yours. How many would you have got out of the 2 points? Or out of the 10 points? Okay? Where are you at? Are you at that 6? Are you at the 8? You at the 10? Or are you below the 6? Okay? Figure out where you are. What do you need to work on? Number 2. Okay? Number 2 is calcium oxide reacts with water. Now, when I'm thinking about this, okay, I think about certain things and I rule them out. Number 1, this is not a combustion reaction. I know that. This is not a decomposition. I know that. This is not a double replacement. Well, it's not a single replacement. I know that, don't I? Okay? Because a single replacement wouldn't have 2 dance partners. Okay? So, as I'm thinking, 2 of them deal with water. Okay? 2 of them deal with water. One of them, I guess one of them happens to be a single replacement. Okay? But it's not this because I do not have an active metal. What do you think? What type of a reaction is this? This is a synthesis reaction. So it's an S. And my number is an S3. Okay? An S3. And an S3 tells me that an active metal oxide plus water yields what? Yields what? What does it yield? Huh? A metal hydroxide. Good. So, I've got my 2 points for my reaction prediction. What type it is. Okay? Calcium oxide plus water. Did you get your 2 points for the reactants? Okay? Did you get your 2 points for the reactants? Now, I predicted the reaction. It's going to give me a metal hydroxide. So, to get my 2 points for the products, I have to have my metal hydroxide formula correctly written. Okay? Calcium is a 2 plus. Hydroxide is a 1 minus. So I need 2 hydroxides to balance out my 1 or my 2 plus. Questions on that? Did you get your points for the products? Final thing is what? Balance. I should be balanced, right? So as I look at this, I'm balanced. Okay? Do a self-assessment. Once again, how many out of the 10 would you have got there? Okay? My third example. Potassium reacts with water. Once again, go back to our objectives. First thing we have to do is we have to determine what type of a reaction this is and what number. What do you think? Anybody have it right now? What is it? Single replacement number 2. Okay? I'm looking at that and I'm saying I'm going to believe, Cassidy, that is indeed a single replacement number 2. Excellent. All right? So we got our single replacement number 2. What's our next step? Okay? What's our next step of our objectives? Okay, formula of what? The reactants. So potassium plus water. My next step is, what is the reaction prediction going to be? Okay, potassium plus water yields what? Yields what? What does it yield? A metal hydroxide and what? And hydrogen. A metal hydroxide. My metal hydroxide is going to be potassium hydroxide and hydrogen. Now, what about hydrogen, Zoe? It's a diatomic. Good. It's a super 7. So we need 2 of them. Okay? So, I've got my 2 points for my type of reaction. I've got my reactants. I've predicted it. I've got my products. I'm at 8 out of 10. My other 2 points are balancing, right? Do I need to? Yes, I do. I do need to balance here because I can see that I'm off balance. So, I put a 2 there. I put a 2 there. And I put a 2 there. Now I've balanced my equation. Get your 10 points, right? My fourth one. Aluminum reacts with hydrochloric acid. Okay? Looks to me like one person is trying to get into the dance. Okay? One's trying to get into the dance. So what type of a reaction is this? No. Okay, one person's trying to get into the dance, meaning it is a single replacement. Specifically, what number of a single replacement? Number 3. Now, this one brings into a little bit new, okay, because I need to check my activity series. I need to check to see if aluminum will indeed replace hydrogen. So, aluminum plus hydrochloric acid, IC 1 or 3, acid rule number 1. So I'm dealing with HCl. hydrochloric acid. Now, who's got their activity series handy? Will aluminum replace hydrogen? Ethan says yes, it's above the line, right? It's above the line. So, I am going to get a new salt. That new salt is going to be aluminum chloride, AlCl3. Did you write the formula for aluminum chloride correctly? Okay. Also, it's going to give me hydrogen gas. Zoe told us before, hydrogen gas was diatomic, so I need to have 2 of those. So once again, I've done my first 4 objectives. I'm coming back on number 5. I need to balance this. This one's a little tougher to balance because I can't just put a 3 right here, okay? I can't just put a 3 right here. It's not going to help me. Why? Because that's going to hurt my hydrogens. I can't have 3 hydrogens, can I? Okay? So what I'm going to do, and I just have to see this, getting used to balancing equations, getting used to this, I'm going to say that I'm going to have to make this an even number so that I get my chlorines to be 6. Can I make 6 hydrogens out of that H2? Absolutely. Absolutely I can. So now all I have to do to balance this one out is put a 2 here, put a 2 here, and when I go back, because I saw this happen on somebody's work too the other day, as I go back, can I reduce my coefficients? Can I reduce them? Once you're done, once you've seen enough of these, make sure you put your entrance slips back in my box. Okay? Hopefully you corrected them. Now, can I reduce this? No, I can't. So now I've balanced my chemical equation. Okay? You folks back working on the lab, make sure you have your goggles on. All right? So get your goggles. If you're just now starting the lab, get your goggles on. Now, we're going to work one more. Okay, we're going to work number 5 here. And this is going to be our last one because we need to get started on the lab then. On number 5, sulfur dioxide reacts with water. As I'm doing this one, folks, first of all, again, what type of a reaction is this? What type of reaction am I dealing with? Huh? A combination or a synthesis. Remember, I want to write these as S. Okay, S what? S what? It's got to be S2 or S3, right? So am I dealing with a nonmetal oxide plus water, or am I dealing with an active metal oxide plus water? Non-metal oxide, correct? So this is a synthesis number 2. 2 points right there. Okay? Reactants. Sulfur dioxide, water. Did you get your 2 points for your reactants? Do you have the formulas for those right? Okay. Now, I've already predicted my reaction. Okay, I said it's a synthesis number 2, so I know what's going to be produced, right? What is it? An oxyacid. An oxyacid. If you remember, when I told you that we're dealing with this particular type of equation, I said let's pretend that we're adding them, okay, and get H2SO3. Does that make sense charge-wise? Does that make sense charge-wise? I see that I have 2 H's, so I have 2 plus. Is SO3 a 2 minus? Is SO3 a 2 minus? Where would I find that? Huh? It is. Where did you find it? On your ion sheet, right? So yes, this makes sense. H2SO3. Now, I've done my 2 points for the reaction type. I've done my reactants 2 points. I've done my prediction of oxyacid. Okay? I wrote the formula of the oxyacid. Okay? All I need to do now, I've got 8 points. I need to balance it to get my 10. What do you think? What do you think? I'm good. It's balanced, right? It's balanced. So, yeah, nice job. 10 total points. Da-da-da, da-da-da.